All right, guys, let's go ahead and look at a density problem that's a little bit more complex. On the right-hand side of the screen, you're going to see Desmos for some calculations. And on the left, we've got a nice word problem to get started. So it says, a machinist creates a solid steel part of wind turbine engine. The part has a volume of 1,015 cubic centimeters. Steel can be purchased for 29 cents per kilogram and has a density of 7.95 grams per cubic centimeter. If the machinist makes 500 of these parts, what is the cost of the steel to the nearest dollar? All right, we got a lot of complex things going in there. But the thing that it does bring up is that it lets us know that we're going to be talking about density. So I'm going to write that out right away. Density equals mass divided by volume. And one of the things that we know automatically is that we know the volume. So I'm going to write that down. We know that the volume is equal to 1,015 cubic centimeters. Okay. And it also tells us the density of this. If you read this, it says the density is 7.95 grams per centimeter cubed. Now, the overall question is, what is the cost of the steel? Well, the cost of steel depends on something. It depends on how much weight or mass there is. So cost of steel depends on the mass that is there. So that is what we need to do, is we need to break this down and we say, well, let's find the mass. Well, the thing that we can do is we can find the mass of one piece. So let's go ahead and do that. I'm going to go ahead and fill in a few things because we know that the density is 7.95. Okay. We know that the mass is what we're looking for. And we know that the volume is 1,015. So how do we solve this? Well, what am I going to do? I'm going to multiply by 1,015. Okay. And so when I come over here, I'm going to look over here and say, well, let's take 7.95 and I'm going to multiply it by 1,015. And that is going to give me 8,069.25 grams. And that is going to be our mass. Well, the one thing that it tells us, if we pay attention, really pay attention, is it says it is 29 cents per kilogram. So what I want to do is I want to convert 8,069.29 grams to kilograms. So let's check that out. What do? We are going to say that there's 1,000 grams for every kilogram. So what I'm going to do, I'm going to take 8,069.25 and I'm going to divide it by 1,000 because there's 1,000 grams for every kilogram. That's going to say that we have 8.069 kilograms of this material per piece. Okay. Now, how many, or per part, let's go ahead and put that so we keep it this. Well, how many parts are there? We are going to make 500 of them. So what is the total amount of kilograms we're going to have? Well, we know that if each one of them is 8.069, we're going to multiply that by 500, and that will give us our total weight. So let's do that. Let's go ahead and take 8.069 and let's multiply it by 500. That's going to give us 4,034.5 kilograms of material that we're buying. Well, how much does it cost? It is 29 cents per kilogram. So what do we do there? We multiply that. So I'm going to take 4,034.5 kilograms, and I'm going to multiply it by the 29 cents per kilogram. And that's going to tell us that the total cost is going to be $1,170. So it is $1,170 if we know that is 0.29 cents per kilogram we just multiplied out, it's going to cost us $1,170. All right, pretty complicated problem there. Having to take into part calculating, using the density to calculate the mass, and then the fact that we are even going even further and saying that there's multiple pieces to this calculation with multiple parts and accounting for the cost of the weight.